Hello, welcome to our channel. And this time we are going to discuss a very important topic in electronics, and that is what is parasitic element. And here is a question mark. So in electronics, you have variety of components. We call it electronic components, and those components have their packaging. For example, your capacitor, your resistor, and your inductor, and you have a diode, you have a transistor. Okay. So in all these components and the devices, when they are designed and manufactured, they are manufactured with the intention of behaving in an ideal way. For example, when you manufacture a resistor, it has to act as a resistor, and it means it will be a pure resistance. However, in each of these components, when they are manufactured, there are some undesirable other functionality. For example, the resistor will have a capacitance and inductance. For example, a capacitor will have unavoidable and unintentional resistance and inductance, and an inductance will have undesirable capacitance and maybe also a resistance. So for example, here you see this is, let's say, a component, and there are two leads to this component. So you see between the two leads there is this capacitance which is called as parasitic capacitance. Then you have an inductor here, you have a resistance here, you have an inductor here, and you have a resistance here. So this figure shows a parasitic elements of a typical electronic component packaging. So that is unavoidable. That is our first point. The parasitic elements are unavoidable. Okay. So in electrical networks, a parasitic element is a circuit element, maybe a resistance, inductance, or capacitance that is possessed by your component as shown. But it is not desirable for it to have for its intended purpose. We don't want these parasitics because we just want the component to function in its original way. So like I said, the resistor has unwanted capacitance, and there may be inductance as well. Second point here is all conductance. Let's say you have an electrical wire. So it's a pure conductance. Copper, this wire is made of copper. So it will have its own resistance if we draw the model, and it will have an inductance, like I said. Okay. So this conductor is having resistance and inductance as a parasitic elements. Okay. And these are the two leads of the conductor or the copper wire. Since you have a principle of duality, if there is a capacitance or inductance, you likely to have a capacitance and vice versa. So if there is an inductance, you are likely to have a capacitance. If there is a capacitance as a parasitic, you are likely to have inductance as a parasitic. So that's the principle of duality. For example, you have an inductance and it is not a pure inductor. It is, let's say, when you manufacture a coil, its symbol is as shown over, and it has certain number of turns indicated by N. So if this inductance is not pure, it means it will have a capacitance as a parasitic element. And at a certain frequency, this L and C will form a tank circuit that will get tuned or resonant at a specific frequency, and above this frequency it will also resonate. It means, let's say here you have a voltage and here you have a frequency, and the frequency at which the signal is maximum is called resonant frequency. So inductor is no longer behaving as an inductor at the resonant frequency and above all the frequency after resonance. It is no longer serving its original purpose. Okay. So discrete components will always have some kind of parasitic values detailed on their data sheet to aid the circuit designer in compensating for unwanted effects. Sometimes the circuit designers take advantage of this parasitic property to modify and improve the circuit performance. So hope you enjoyed this short tutorial on what is parasitic element, why it is present and it is unavoidable, and all other properties of the components. So if you like this video, click the like button, do share with others, comment on it, and subscribe to the channel. Until then, stay tuned for more enriching content on our channel. Till then, wish you happy learning.